mentioned in my last video that I wanted to tackle a project where I would recreate this wiring diagram that I've been referencing into a digital version. There's a couple of reasons that I would want to do this. A few of the main ones would be that it would become more easily modifiable. There are some modifications I'm going to be doing to the light circuits that I would like to have reflected in the schematic. There's a few things that I'd want to clean up. I'd want to put tags rather than these long wires. So on the right side of the screen, I'm in a program called KiCAD, which is actually a circuit builder, or I guess a CAD program where you can actually create PCBs. If you wanted, you could do up a schematic, attach the pins from the schematic onto a PCB, do a layout, and actually turn that layout into some manufacturing files that you could then manufacture PCBs. For this specific project, the reason why I'm using it is because I'm just a little bit quicker at using it. I like the hotkeys, and it's fairly easy to make circuit symbols for the ones that may not be available. So I'll get right into it. I've already started by creating the different sections of the wiring diagram that I want, and I'm going to start where all of the voltages start, and that's going to be at the battery. So I'll start in this front left circuit, and I think for this video what I'll get to is finalizing some of the handlebar stuff, and then I'll see where it goes from there. Another benefit to making this digital is I can have everything be horizontal in how it's printed. So even though I have different wires, I can make sure everything reads from left to right, top to bottom. So here I have fuse box A, B, C, and D. I've kind of gone and said this is fuse A, fuse B, fuse C, fuse C. I can actually just edit that. Again, this is not a tutorial on how to use KiCAD because I feel like that would be best done with a circuit board project. However, that's something that I guess I could do in the future, although I'm not very experienced with it. From here, we notice that there's multiple lines of power that go towards this, plus it's not that huge power line that we saw at the battery before. At the battery, we see this super thick wire, and that basically allows this starting circuit to have a lot of current because it's directly from the battery. I'm sure that you've seen a battery arc and voltage. Anyways, it can blow stuff up if it doesn't have its power kind of like controlled and with circuit protection and that kind of stuff. Now, if we go down here, we see that those wires at the top, now I guess I can't really trace it, but if we follow this line here, it goes all the way to the right here, and then it basically goes straight down into this blue-orange. So that's the blue-orange that I see here. That is the power side of the fuse, and then the the black and blue line coming out would be going towards something else, which we'll deal with in a bit. Now, where does that blue and orange wire come from, and why is it there? We see that there's also red and black, which is another line that goes to that fuse block. But what these come from is this little pinout here. Now, this is just kind of like a power distribution block on the motorcycle. It has four pins, and it just is basically a junction where power comes in and power gets redistributed out for the different circuits. So I might actually just draw that in just to make sure that I have everything in the diagram, and I'll do that right now. something that I just noticed here. I'm going to redo how my starter solenoid goes, so I'll make those changes right now. The red and white wire is actually one that goes to power the rectifier, and this is that the rectifier is just what turns the AC that's generated from the from the alternator into DC, direct current. The R is actually what is going to our power junction here, so it's labeled BAT1, and as the red comes in, it will get redistributed to everything else. Fan, that's just for the fan because they generally use quite a bit of voltage actually for the cooling fan for the radiator. Ignition will use another significant amount. And then VC, where this motorcycle doesn't actually have a full engine module, so the ignition control module is pretty much as close as we get to an ECU or a engine control module as there is, although there's not that many pins on it. Most of it just goes to timing the ignition as the engine's turning. But these other two, so ignition, if we follow over here, we see that the red and black would have then gone from ignition, so the battery came in from here, and then the red and black then gets fused. So there's a main fuse here, meaning that a total of 30 amps is able to run on the entire system or come out of the battery, whereas for all the smaller circuits they also have an individual fuse block and a capacity for each of them, because we don't want to be running 30 amps through like a signal light or 30 amps through some sort of LED. This blue and orange wire here just goes for the fan. That's why it looks like it's separate, because it doesn't really match everything else that's going on the car. So from here, I think the next thing that I'm going to do is just create a small legend at the bottom that shows which fuse gets which power. Okay, so that's where I think I'm going to stop today. Just to kind of give an overview, it doesn't really look like we've done much. However, we learned a little bit of about the circuit. As a recap, we know that the circuit always is going to start at a battery, right? We need some sort of power source. So that power source is going to have ground on one end, and that's what this symbol here is. And then the positive side of the battery needs to be fused. So that's where we see it come into this large terminal, go through the fuse, and it's attached to this pin. This pin now is going to redistribute all of that power. And remember, it is already protected, it's already fuse protected here, and it's going to send it out to various components. And this is how your lights and everything can turn on without your engine running. Now, when the starter motor is engaged, when you're trying to start the car, we see the signal come in from this yellow-red wire. And what this yellow-red wire did was allow this circuit to be closed and allow this coil to become magnetized to the point where there's enough current through it that it kind of created a magnetic field that would pull these contacts closed and allow this battery power from here, voltage, to then pass through this metal piece here and then back through the other side of the terminal, and that allows it to go to the battery, which is also grounded on one side. So when you release that signal from YR, which is literally just on and off with your starter button, or in an automotive circuit or application it would be the key turning, when it's not engaged it won't just keep running, but everything else is allowed to keep running. The next thing that we noticed about the circuit that I actually didn't know before was that it had this distribution here, so that one of those power lines came in from the battery and then it got redistributed to everything else. Two of those circuits were a blue and orange, and a red and black wire here. Those became fused, as we can see here. And then the other wire was actually a wire that went into the ignition control module. So we'll dive deeper into more of those circuits later. However, this is where I'm going to stop right now, as I'm getting a little bit tired. But I'd like to then go into the actual stage where we are starting the bike. and we're starting to use this switch, and what happens to the circuits as we do that. Because there's a few other things that are involved with actually starting the car, a few things that get checked. If you own a bike, you know that it waits till you're in neutral. It requires you to have the clutch switch on, and you can't put it in gear with a kickstand down, etc. Those types of things. So we're going to go into how that looks like on an electrical, like a wiring diagram, and how those signals all get incorporated into a circuit schematic.